So once again, thank you for inviting me on this event, this hard times. Thanks, Aleksandrov and Mikhail, for this. So today I'm going to talk about Helidon, the project I'm actually working on. And thank you for your interest. So just usual Oracle slide, like before taking any of the business decisions, just check if everything is in the same situation it was in this presentation, because things may change. We will be quick at the start. So my name is Dmitry. I'm part of the Helidon team working at Oracle, currently in Sofia, and I'm very pleased to be here. So we have an agenda like this. I'll explain with you what a Helidon is. Since this is a Kotlin conference, so conference tech talk, so we will dive a little bit into support. We will see why Reactive is a good choice and how Helidon does support this. And we will see a very small demo for you, specially prepared demo for to demonstrate this technologies and to demonstrate how it's done in Kotlin, in Helidon, with a lot of goodies inside. So if you wonder what Helidon is, actually, we call ourselves this as a set of libraries, Java libraries for developing microservices. And Helidon, I personally love this word very much, and the name choice very much. It means swallow. So very fast maneuverable birds fly somewhere in the clouds. And it so represents the idea that the microservices are somewhere in the clouds, and they're so fast, tiny, maneuverable, like the swallows. The good thing is that it is available under Apache 2.0 license, and it's fully asynchronous, built on top of Netty, making it so fast. And as I say, like it's flying in the clouds, it's cloud native ready. That means that out of the box, you have everything what you need to run the clouds. It's like not only serving you REST requests, but also metrics, tracing, health checks, everything you need there. And to make it even more faster with an awesome startup times, we have like really full support for GraalVM, which we're really proud of. I will tell a little bit later about it. Once again, it's Java libraries, but still we will jump into Kotlin a little bit later, since we support it very nice. The things I wanted to mention is that it's actually quite a mature project. I mean, it started back in 2015, actually, but it was productized in 2018. And now we are approaching version 3.0 of it, which will be available quite soon. So as I say, it's really small and tiny. Small memory usages, really great startup times. And as you see, we have 3 of them. So that means we have native, and we have JLink and JVM. That means that we are, from the very beginning, modular. We're living in Java 11 plus world, which means that you can create even your custom JVM, custom images with your JVM and Helidon product, just throwing away all the things you don't need, making it very fast. And if you go to native images, it's really very fast. So this is actually the overall architecture. So it's very high level architecture. So you have Netty, which means that Netty is underneath. It stores everything for us. Then we have created a special layer, which is fully reactive. We call it Helidon Reactive or Helidon SE, as we are following pure Java ideas there. And to make it very much portable, we have a layer on top of it, and we have chosen to be part of the micro profile specification, which means that the code itself is very portable. Just a few words about it. So as you probably know, that this micro profile is a set of specification, open specification for creating microservices. Specifications means it's not an implementation, but it's just a standard which all vendors implement, and Helidon is just one of them. Which means that migrating to Helidon from any microprofile specific framework will be very fast. So you just drop in the code and it will work. And you will receive not only the typical microprofile specification, as you see here, there are 13. They're all about microservices. What does that mean? So as you know, microservices is kind of a example of distributed system, so distributed computing. That means that you have everything for that. So all of them can fail, unpredictably. So that's why I have fault tolerance. They have to be traceable and have a good observability. That means you have metrics. For security, you get JAWS, and this is like specifications, especially for the microservices world. And with Helidon MP, you get even more of them out of the box. So you have the microprofile specific annotations. Then you also have some Java E specific stuff, although I should say intentionally, explicitly that Helidon is not a serverless container and enterprise, big enterprise machine. We are small, but we still support some of the Jakarta stuff. They're like WebSocket persistence, transactions, and RESTful services as well. We also support some specifications which are like under the umbrella of microprofile, but they are still like not in the core specification. One of them is microprofile GraphQL cores. gRPC is not part of it, but still we do support it. And we have started support is not written here with the YAL array, so which means that distributed transaction following the Saga pattern, we also do it out of the box. But if you remember, so the overall architecture, we have this intermediate layer, which is Helidon Reactive or Helidon SE, as we call it. And actually, welcome to the danger zone, as we usually say, because here you have all the same stuff or even more, but it's pure Java, fully reactive, and extremely powerful. As far as I know, that in the world of Wolt, so you have to be really powerful, because whenever somebody wants to eat, like everybody wants to eat on all the same time, so you have to stand little timing and huge pressures. And I believe that the idea that Helidon has this two as we call it, flavors, choose you exactly what you want to do. If you want a portable stuff, you can choose MP, but if you want performance without any magic happening there in the microprofile CDI world, etc., you would like definitely to choose Helidon SE. So that means we do support the same specifications as in P. They're actually the foundation for specifications which are supported in specifications of MP. But we have even more. We have reactive streams, reactive messaging, reactive web client, and reactive DB client. I'll talk about them a little bit later. And that means that pure Java, pure performance, and we got it out of the box. So you see here, the numbers are really tiny. So you also have this modularity that you always had in MP, but you got some smaller startup times for everything. And before actually going to Kotlin, the funny thing is that, for example, here in Helidon MP, we all support CDI, not CDI, but 12VM, but in MP, we support CDI even in microprofile, even in native image, which makes it really cool. It makes this one of the coolest product actually, because you can compile to native image even with CDI, which is awesome. And we do support Kotlin 1.6.0, and I just want to say a few things about it. So actually, the support of Kotlin came to our mind like about a year and a half ago. We say that Kotlin is a very good, pragmatic, awesome language. And we actually started exploring how we can get into this world. And we're quite happy. So I was in charge of this, that it was actually possible. And not even possible, but also created our own special DSLs for writing your application in Kotlin in idiomatic way. So this is something that we were talking about with Anton or Hippo from JetBrains, that there is an idiomatic way of doing Kotlin. And that's why we created DSLs for the ease of it. And it was very, very easy because in Helidon SE, we use pure Java and a lot of builder pattern. And so we have a lot of builder pattern. That means you don't have to do this boilerplate code like builder, then builder pattern, then build. So you can create just a DSL for that. And this is what we did. So if you want to create a web server, you don't need to use builder. You just use our support for that. So we have Helidon Kotlin support dependency. And got web server, you just put in the routing configs, etc. I'll show you this in the example later, and it will work. Next thing, we have created some language extensions there. So for example, we used a lot word as, which is a keyword for Kotlin. So that's why, to make it beautiful, we created some extensions for all of our functions which use as, just to make it Kotlinish, I would say. I'm not sure if I just invented a new word, but we did it, and it has this support. So that means that Helidon does support. And once again, for this presentation, we have chosen to give more of the reactive flavor of Helidon, since it's all about performance. So that means whenever you have a lot of performance, reactive is now the current way of doing stuff. Although I'll just share with you some news. So as Project Loom comes, Helidon already has Loom support for that. And in some of the future presentations, somewhere in the conferences, I will give you numbers for what is the difference between reactive and blocking Loom support and doing stuff. But once again, performance now these days is achieved with reactive stuff. And Helidon, as you know, in this EC part, is definitely doing it in one of the best ways. So whenever you want to create a server, you just use the web server DSL for that. So you will create routing, configs, and add media support. And as I say that, directly jumping to the Reactive Engine, you will ask yourself, okay, what is reactive actually, and how do you support reactive? Are you using some engines like, I don't know, Reactive Project React or whatever it is? Actually, no. We decided to do it our own way, and we created our own implementation of Reactive Engine to have our own ecosystem for that. And it's good because, as I told you, we started from Java 11 from the very beginning. That means that we have created our sets of reactive operators built mostly on following the Java to conclude flow reactive streams. So that means that we have our own engine, and we're very proud that this engine was mostly contributed by the actually creator of the idea of reactive stuff, reactive programming, David Karnik himself. So it's one of the most performing engines you will ever see. But so we have created our own representations for operators. That means that for multiple operators, get multi, for single value, get single. Just to give you an overview how it looks, for example, you have multiple values. So you created a stream of 1, 2, 3, 4, 5, and you just map it, and you have all the set of operators to work on it. It's the same for single, actually. So if you have only one value, you also can do all the manipulations following our rich set of operators here. So what does that mean? You have actually all you need to do to live in the reactive world. And you have all the operators for them. With this list I have provided. So I won't tell about all of the lists, but still it's available in the documentation, but still it means that all the operators that you do have are all you need for the reactive world. We have it as an operators. So as you know, FlatMap does the most of the stuff. We do have it as well. You can also chain your operators. So that means that whenever you have some functions doing several stages, you can compose them easily. So there are operators to compose the stages and to make everything, the flow of these operators quite easy. So, and as I said, I'm quite happy that the performance that you will have. This is a GMH benchmark created by Daniel Ketch. He's one of our colleagues in, friend as well, colleagues in the team who was actually mostly responsible for Reactive. And you see the engine itself is very powerful, and it means that most of the operators are really fast, sometimes twice faster than the competitors. Yes, this may be reviewed, but I know that small right guys are awesome and they're doing awesome stuff. And but still, we are in a good competition with them, and Helidon does provide you this. More than that, so you have Reactive Web Server, you have Reactive Engine itself, and you have a lot of other stuff like Reactive Messaging, for example. So you just add a dependency, and you can create messaging. So we're following mostly the ideas of micro-profile Reactive Messaging. So we took this as idea, but we created absolutely independent implementation. So for example, if you need something like publisher as a subscriber, you have an abstraction for channel for that. And you have to make chains with publisher, processor, and subscriber at the end to create messaging, actually to do the messaging for you. Once again, it's written in Kotlin, so you just create a channel. You publish some information there. As you see, multi means that it's reactive, so several reactively presented elements of data. You just map it, and then you just print it so with the listener. So it means that you can easily publish something to channel and then subscribe to it. You can drop something in the middle with the processor. Like for example, you have you see, by the way, you see how it is. It is done with DSLs right now. So that means, although in the core it's Java, so you can easily do it with DSLs, which are available with the Kotlin support. So you just create a publisher, map some information, then process the information, and then add a subscriber for it. And then you have all the messaging you need. So once again, the main difference between Reactive Messaging in SE and MP is that there's no magic philosophy of SE, so you don't have to do annotations and such strange processing there. You just write a pure Kotlin, in our case, code with DSLs, and it will work out of the box. And as I said, messaging, we have a good connector to external messaging. Systems like Kafka, like JMS, like ActiveQ. Quite soon we will have our socket as well. Actually, it is already available as a PR, so we just need to include it in the version. So that means that you have all the transports you need for your messaging. And then we have some goodies, actually, as I call it, reactive goodies. Since reactive means that all of your stuff has to be reactive. That means you cannot do everything in terms of, this part is reactive and the other part is not reactive. Everything has to be reactive. And since we know that Helidon is for microservices, microservices can also work with databases. They are not somewhere, completely disconnected and stateless. And that's why we created a so-called DB client. DB client is a reactive client to databases. It is cool because it actually makes any of your blocking JDBC drivers like unblocked. Yes, and it's achievable with an abstraction. So you actually, your driver runs in a separate executor. You don't care about it. You only have a driver. It runs in a separate executor, and you talk reactively to this driver. So it may actually block somewhere in the executors, but you from yourself do not block. And that's why we have this client specially created. It does support but all of the JDBC drivers. So just to JDBC and abstraction. And the other thing is that we don't support also a non-SQL basis like Mongo. And it's funny because the client abstraction itself, so the API you're working is very close. So that's why we have a common API for both SQL and NoSQL databases. So this is how it works for working databases. The cool thing that you just use the client, and then in the properties you just specify everything you need about how to connect it, and you can even specify statements there. So I will show you in our example, which I specially prepared for you. And since microservices not only provide data, like they serve data, they also consume data. We have created our own reactive web client. What does that mean? That means that you are able to talk to other services in reactive way as well. So that means that with Helidon SE, you have everything to work in reactive way, totally reactive way. You provide data in reactive way, you're working reactively with messaging, you consume data from other web services with in reactive way, and you persist your data in a reactive way, which makes it really cool. And I believe it's a good time for a demo, just not to show you how good it is. Let us switch a little bit to our examples. So I hope you can read well. If some of you cannot read well, I monitor the chat. So just say me or somebody to interrupt me. I can increase the font for you. So especially for this event, I have created a small demo. It is like a small delivery service, which uses several technologies all in together. So first of all, I've created abstraction delivery. It's extremely stupid. So I know you have, yeah, thank you, Hanan. So you can see it well, thank you. I know it's extremely stupid, but I didn't want to go into much details. So we have a delivery which has an ID, some food you want to be delivered, and some address, and to see the tracking information to see how fast it will be delivered, you have the status bar. You have a special service. So actually, let's go to the main method. Here's the interesting part. So we have to work with delivery and have to serve it somehow. It's a lot of Kotlin, but as you see, it is idiomatic Kotlin, which means that we're totally following Kotlin's ideas of representation. We don't have main methods that we have in Java. So we just need to start a web server. And you see, it is done in a reactive way using DSL. So as we say, we need a web server. This web server has some routing. So that means that for several routes, you will have your handler. It reads the configuration from the file, so just server. And we have media support for, we have trace, because we want to trace, for example, everything, to apply tracing here. And we have support for JSON. It can be both JSON-P and JSON-B. You only have to explicitly add it just because it's so much modular that if you, for example, want JSON-B and not JSON-P, just throw it away. And that's why your starting time will become even faster. And then we just start the server, and you see with all this that accept, that means the server is reactive. When the server started doing it reactively. So whenever it's up and running, you just say hello world. And as I said, routing, we need to create a route for our customers. That means that, for example, for the database, we have so-called delivery service. If we go to delivery service, we're using especially this delivery DB client. So when the service comes, we just store this delivery in the database, and we send a message to our, let us call it, I don't know, invoicing service, and it will be sent via message, and this message will be encrypted with just for purposes of this demo, I have also included our HashiCorp Wolt support. So we will use HashiCorp to encrypt our message, our information that we're sending. So we also have our own custom support for that, and it's out of the box and it's already Kotlinized as well. So as I said, DB client, we say first of all, drop all objects for the sake of the demo, and we say that okay, please create the tables for us. As I say, create the table. That means that this is the setup file for the application. Is just a pure YAML file. But here you see we can even create our statements inside of this setup, which is good because whenever something changes, you don't need to recompile it. You just say, okay, this statement works like this, and it simply does. And what we have, let us jump to the service. This service, wait, yeah, here it is. Oh, no, my bad. Delivery service is actually extremely stupid because the other thing you need it to become working in Helidon is just to implement the service interface. And this service interface has only one method. It's called update with routing rules. And it just updates the rules of the server. And here what we do, we say to the rules, okay, for the methods that we do have, just make it a handler. That means that, for example, if you have a GET request for this this path, it will just list all the deliveries to our response, as it here. If we want to create a delivery, we just create it. I have created a special post method with fast delivery. So we are so much hungry that we just do this URL and it will immediately request it. And as you see, we just have request object, which comes from the client, and we can generate response object. You see, it's really, really easy. And then, as you see, they have this handlers, and these handlers are just private functions when you realize or implement, let's say, your stuff. For example, if we have to insert a delivery, so we just create a delivery. We get it out of a response, a request. So we read the parameters. And next thing, we just encrypt this data, for example, for the invoicing service. And it all works reactively. So we have a crypto service. It uses encrypt service, like it gets delivery, so it encrypts the information. And then after it is encrypted, we have a special Kafka service used for messaging that I actually demonstrated you earlier, just to emit the message and send it. Here we have, just for the purpose of the presentation, I have created a channel to print it via WebSocket. So we just print it to WebSocket to some site. I will demonstrate how it works. So whenever we create a new request, it just encrypts the information for invoicing, for example. It sends it to a Kafka queue. And then via WebSocket, we just receive it to some, I don't know, I'm sorry, I'm not sure how it works exactly in Vault, but I improvised. And it just goes to some endpoint when somebody just handles this information. And then what we do, we just store this information. As I see, these two things happen in parallel, which is good. It means that sending a service is not connected to storing this information. We don't need to chain them. And this happens in parallel. And as we say, we just create a query, we execute it, and we just insert something. If something goes wrong, we exceptionally handle this information. And basically, this is it. So the flow is so easy. We have a delivery, which is being with this delivery service, we just have map our endpoints to handlers. We store this information in the database, and we have like a service to publish it to any messaging. And we have a crypto service, which is once again, it's very easy. But because we have built-in support for example, HashiCorp, and it just encrypts and decrypts the values for us. And WebSocket endpoint is very easy. It's just, puts all the information that we received in an encrypted way to WebSocket. I will keep it encrypted. I won't decrypt it, just for this demo. Now we have an index page which we serve as static content, and you see it's so easy. Once again, everything is configured here. So a server on this port, static information on this port, Kafka. We say, well, this is Kafka. We say that we want to trace all the JDBC stuff because we have integration. So the drivers are not saving everything, but they're also tracing the information. You can easily see how it works. We have DB. I just keep it very simple, H2 database. And you can also see that we all do all metering there as well. So in the health and tracing information, it will be available with some queries and the Vault. As easy as that. Now I will try to run this thing. So first of all, I will run the Kafka server just to, hopefully it will work. So it's loading just a container with Kafka. Yes, it's ready to use. Another container I will use is the Vault container. It's HashiCorp Vault. It's another image running in the cloud, in Docker. And what we have, we will just go to the main method. You see, it's main. It's nothing magic. It's main. That means that we can easily start it from the idea, and it's started. It's even printed a lot of information for us about how it is, what is connected. So I just make it very verbose output. And let us do something. I will call another console, and I will do some curls. I say that I want some sushi in the city of Tampere. I've been only once there, so beautiful city, and I just add a status new for it. Oh, what is it? I like it. So I really like it when the demo gods are not with me, but I will just start and stop it again. It's because of the H2 database. As we I hope it will work. It worked before the demo, but once again, demo gods. What's wrong with it? Failed to prepare a statement with parameters. Oh my god. So confusing. So sending service, delivery service, insert service. Let me just clean it up. So the Kafka should be running. Let me check all of my Docker stuff just to be completely sure. Dashboard. Yes, they are actually both running. Kafka is running, Wolt is running. Prepare to prepare statement. Let me do one thing. I think I've changed something in just before this demo, which is not the right way to do it. Delivery service and delivery service should be with some changes. Just I'm sorry for doing this. With local history. Yeah, I just need this thing. So exceptionally, then run, then exceptionally. Let's try it again. So we have connected. Well, let me just check if then prepared the database. It should have prepared it, so it gave me the LESSL keys. Well, let me try it again. Yes, it worked. Oh my God. I'm so sorry, but it did work now. And what is cool stuff? We have inserted a new thing in our database. And here, for example, I will just reload it. I will do another insert, like not in Tampere, but in Helsinki. Helsinki, like new. Just give it our name. So it did insert this value. And as you see, via Kafka, it sent it an encryption information to our WebSocket, which automatically appeared. For example, for invoicing purposes. So that means that in one application, we used everything. Pure Kotlin with DSLs, database in a reactive way, encryption service in a reactive way, WebSocket in a reactive way, and all of that just with those several classes. By the way, just to mention, we have automatic mapper for back and forth for JSON and objects, and here we're using some of the DSLs, how to convert this thing. So this is what I wanted to show you. So Helidon is definitely a good choice for you because it is. I'll just jump back to the presentation. Very fast. All the integrations are done with Kotlin out of the box. You have everything: database, web client, web service, messaging. Work with Wolt out of the box in a reactive way. And with this flavor of Helidon, you're actually easy to use it. So we work hard with this to be true and possible, and I definitely would recommend you trying it one day. So thank you so much. It has been a tremendous pleasure to be here today.
Thank you, Dmitry. So I'm leaving the chat. I left the note there. So if you have any questions, please feel free to shout out them during the next 20 minutes when we have the final presentation.
Yes, and just whenever you have some questions, you can just tweet me at Brecker2000 or write me an email. I follow this socials. So the question is, Gradle is also possibly. I would call it, I'll be completely honest, there we're mainly focused on Maven, but we don't have any special support for Gradle, but whatever you can do Maven stuff with Gradle, just feel free to use it. So I've tried it for most of the examples, it works okay. Thank you.